Dear student, this is the Ellingham diagram, which is very useful in pyrometallurgy. This is a graph plotted between gives free energy of formation and temperature. So this is the gives free energy of formation and temperature, and it is give free energy starts with the 0, -100 to -1200, and temperature from 0 degree Celsius to 2000 degree Celsius. Now we have to study all these graphs to understand all the points related to Ellingham diagram. The first of all, the graph of metal to metal oxide goes upwards as delta G naught increases with the temperature. You can see this graph, this is also increases upward. All the graphs increases upward in upward direction. Only formation of carbon monoxide, it goes down, right? So the graph of metal to metal oxide goes upward as delta G increases with an increase of temperature. The second point is, all the delta G naught changes follow a straight line unless the material melts or vaporizes. Let's see the oxidation of mercury and oxidation of magnesium. In both these substances, first of all, the graph goes in a straight line upward, and after that it changes its track, and within a short range of temperature it rises up. Similarly with the magnesium, at 1200 degrees Celsius temperature, from 0 to 1200 degrees Celsius, it's a straight line moving upward slightly, and after 1200 it abruptly increases. Now the third point, the value of delta Rg naught for the oxides such as HgO and Ag2O become positive at high temperature, and these oxides get decomposed at high temperature. That is silver oxide, mercury oxide, they are at higher temperature and they get decomposed at a very high temperature. The fourth point is, metal oxide having greater negative value of delta Rg naught is more stable. That is magnesium oxide, aluminum oxide, they are more stable, and having positive value of delta Rg naught are less stable. That is oxides of silver and mercury, they are less stable. The fifth point is, metal oxides placed higher in the diagram can be reduced by the substance lying below it. We can say that oxide of zinc can easily be reduced by aluminium, because aluminium lies below the iron and zinc. And for example, aluminum oxide, zinc oxide, iron oxide, etc. can be reduced by magnesium, but Fe, it cannot reduce these oxides, because Fe is above of all these oxides. Sixth point, if the difference between delta Rg naught of two oxide is large, that is difference of delta Rg, if it is very large, then the substance lying below in the diagram can easily reduce the oxide, metallic oxide lying above. For example, aluminium, it can reduces zinc oxide, iron oxide, and copper oxide. More readily than zinc. The reason behind these is, see the difference of their delta Rg naught. They are very close. There is very less difference in their values, so they cannot be reduced, while they all are having very large difference with magnesium. So magnesium can easily reduce all these oxides such as aluminum oxide, zinc oxide, iron oxides. The next point is, reduction process also depends on the temperature. Aluminum can not reduce magnesium oxide because magnesium lying below the aluminum, but after a point A, this graph rises upward, and this shows that magnesium can now easily reduces aluminum. So aluminum can reduce magnesium oxide because the line Next point, reduction process also depends on temperature. Aluminum cannot reduce magnesium, but after point A, aluminum can reduce magnesium because the line for MgO becomes above the line of Al2O3. Means, first of all, magnesium can easily reduce aluminum oxide, but after a certain temperature, when the line crosses the line of Al2O3, then magnesium can easily reduce aluminum. Next point, greater the stability of metal oxide, more is the tendency of corresponding metal to undergo oxidation. We have to follow a decreasing order such as magnesium, aluminum, iron, copper, mercury and silver. They are in the reducing order. Another point is, there is a point in a curve below which delta G is negative, so that oxide of metal MxO, that is M stand for metal, is stable. Above this, MxO will decompose on its own. It means it can easily decompose.